subject, industrial motor control. This time, we will take up magnetic across the line or direct online magnetic starter forward reverse operation. You know, it is really necessary that you will know this because this kind of circuit is really important today. Now, the typical example of this is the elevator. Now, you will notice the elevator is up and down. Or even the escalator, there is up and there is also down. Or anything that will work in opposite directions, then the starter that they are using there is the forward reverse. Now, in the forward reverse, this can be a manual operated or a remote controlled operated or automatic. But today, I will be introducing to you the forward reverse magnetic starter controlling a three-phase motor. Again, a three-phase motor is a prime mover. So, I have here the materials that you will be using. No? What I'm going to do now is I will just simply introduce to you the materials used, and then at the same time the diagrams. But as to the connections, that will be another video, because I'm going to demonstrate to you the principle of operation, and then we will really do the actual demonstration. You will really see the motor run in forward, and then if we are going to push the button reverse, the motor will change its direction. So that is very important. In our last video, I told you on how to reverse a single phase motor, particularly the capacitor start induction motor or a split phase motor. Then I told you also that the difference between the forward reverse in three phase and single phase is only the power circuit, because the control circuit are the same, but it differs only in power circuit. And I also discussed on how to reverse a single phase and a three phase motor. So today I will be explaining to you the diagram. Okay. So diagram here is also very important, and you know what is also necessary for a technician. You can easily interpret the diagram. Then upon seeing the diagram, you know already what are the materials to be used. But first and foremost, you should know the load. If it is a motor, then try to determine the horsepower, because from that motor, you can also identify what are the materials to be used. So first, you have to find out the voltage, the horsepower of that particular motor, and then that's the time also that you can request materials intended for that particular motor. So if that is 5 horsepower, possible, your materials, particularly the contactor as well as the overload relay, it should be also good for 5 horsepower. Okay, so that is the important one. Now, I told you that if that is forward reverse three phase, you will be using identical contactor. Identical. Meaning to say, if one contactor, if this is the forward contactor, if this is 5 horsepower, if possible, the other one is also 5 horsepower. And then the overload relay, the overload relay, you should also know the full current of the motor, so that you can also buy overload relay where these are the adjustment of your ampere or your full load current. So if the full load current is 20, so you may adjust it to 22. Okay, if that is more than 22, then you might adjust it to 26. And then of course this is also good for 18 amperes overload relay. But this type of overlay is not actually the same brand with the contactor, but I try to combine it. Okay. Now, another information about this is, if possible, it is identical. But if it is not identical, see to it that what would be the horsepower of this should be the same horsepower in the other one. If this is your forward, then this is also your reverse. Now, I said identical. If possible, the magnetic contactor that you will be using there should have three main contacts, of course, because that is three-phase. And then you have also a normally open contact, auxiliary contact. Then you have also a normally open auxiliary contact. Then I'm going to tell you the purpose why is it that we need a normally closed auxiliary contact. We learned that we need auxiliary contact normally open, and this is the intention of this normally open here, the 13 and 14, is to maintain the flow of current, serve as the maintaining contact, serve as for the holding circuit, this holding circuit. So you have here the normally open auxiliary contact, then you have three main contacts, then you have here the normally closed. So since this is identical, you can find the same here. Then you have here your terminals for holding coil or magnetic coil. Okay, so now what you are going to do is you have to connect the power circuit, of course. So that is it. So I will explain to you first the three-phase motor. We learned in the previous video that in reversing three-phase motor, you interchange any two of the three leads. Okay? Any two of the three leads. So, this is now the power circuit. Power circuit. Okay? This is now the power circuit of your forward reverse magnetic starter. So you have here the main contacts of your forward reverse, this one, and then you have also the forward reverse, the contactor for reverse. Then you have your overload relay here, and then you have the motor, of course, you have the circuit breaker. Now, if I'm going to press the button forward, of course, this will close. Okay? That will close. So if you want to reverse the motor, take note, if you want to reverse the motor, you stop the motor. Then you will only reverse the motor if the rotor is in full stop, no extra rotation. Then that is the time that you will push the button forward, reverse. Now, remember when you off the forward, okay, then the motor is disconnected from the circuit, but there is still an extra rotation. So while there is an extra rotation, do not switch on the reverse because it might destroy your motor or damage your motor mechanically, particularly if there is already load. So see to it that when you reverse, the motor is in full stop. Full stop. Then that's the time that you will press the button reverse. No? Okay? So you have here the power circuit. Look at the power circuit. Okay. Now, I'm going to draw here your control circuit. Okay? Your control circuit. Then I can immediately give you the diagram. But for me, I will always explain to you the diagram. Now there are two ways in making a control circuit. There is what we call electrical interlock or mechanical interlock. Now in electrical interlock, before I will draw the diagram, the electrical interlock, no, you are only using the normally closed. That is why possible your magnetic contactor having normally closed auxiliary contact, because we can use this for interlocking. But there, when you buy a magnetic across the line starter forward reverse that is already enclosed, no, in a motor box or control box, in the middle of your contactor between the two conductors, there is a mechanism there, a mechanical part. And then, what is this mechanical part? So, when you on the forward contactor, the motor is running forward. While the motor is still running forward, then intentionally or unintentionally, the push button reverse is on. But remember, this will not reverse the motor since the forward is still in operation. And why is it that it will not reverse? Because there is an interlock there. Okay? There is an interlock. So you have to off the motor so that the mechanical interlock will go back to position. Then when the motor is in full stop, that's the time that you will push the reverse button. Then the mechanical again will lock the reverse contactor. So if you will press the forward, it will not run. Then you need to stop it again to let the mechanical part go back to its normal position. Then that's the time that you will again on the forward. Now, if you are using the auxiliary contact normally closed, of course, I'm going to demonstrate this or illustrate this to you because you can actually understand without this diagram, considering that you are new to this. So here, you have here your overload contact, no? Then you have your push button, normally closed. Then that is stop button. Then you have your forward push button. Then you have your holding coil forward. Okay? Of course, you have your maintaining contact for forward. Okay? So if this is your off button, then this is your forward button. This is your forward button. So if I'm going to press this, of course, this will energize. Diba? Then this will close. The maintaining contact will close. Then the current is flowing directly to your forward contactor. Forward coil. So if you want to off, you off. Now, how about the reverse? The reverse will be this one. There will be another push button there. Then this is your forward or rather reverse button. That one. Then you have your reverse contactor. Then connect this there. Then you have your maintaining contact. Then this is coming from reverse. Okay? Now, just imagine, this is without interlock. Just imagine, if I'm going to press the button forward, of course, this will energize. So the motor is running. Now, if it happens that I will, while the forward is in operation, then immediately I will press the button reverse. So what will happen? The current will flow here. It will go directly to reverse. So what will happen if that is still forward, then you reverse it? It will create a short circuit. Now try to analyze the power circuit. So when you on the forward, then immediately you will also on the reverse. Instead the current will flow to your motor, it will go back to another line. It will create a short circuit. Then the motor, or rather your contactor, will be damaged. So you need to be careful. So how to avoid this? That is why there is a mechanical interlock. If you are using mechanical interlock, no, there is a mechanism in between the two contactors. So maybe I will show you that in the next video. Now, if you are using normally closed, you will place here in the center, here, normally closed. This is coming from forward. Then you have also another interlock here coming from reverse. So this one serve as your interlock. That one. That is your interlock. So when you press the button start, okay, so this will energize. So since the forward contactor is energized, what will happen to your interlock? This will open. Okay, that will be open. Oh. Because the forward is energized. So while the forward is energized, or the contactor is forward contactor is energized, then you press this button here. The reverse will not energize because of this interlock. It's still open because the forward is still running. So what you will do if you want to reverse? You need to off first, then this one is de-energized. Then when this is already off or out from the circuit, this will go back to normally closed. Then when the motor is in full stop, then that's the time that you will press the button reverse. So when the reverse is energized, and again, the forward here, interlock of the forward is also open because this normally closed is taken from the reverse contactor. So interlocking is very, very important. Look at the diagram. This is the control circuit of your forward reverse magnetic starter controlling a three-phase motor. So this is very, interlocking here is very important. Okay, interlocking here is very important. So you are using one off button, then two push button start. So you have here, I have here a sample of the forward reverse push button. You have here the forward, you have here the reverse, and then you have here the stop. So if you on the forward, okay, the motor is running in clockwise rotation. Then you want to reverse, you off first. Then look at your motor. If the motor is in full stop, that's the time that you will press the button reverse. Okay? This is the push button. Then, if you are not using the surface type, you can use the flash type. Okay? You can use the flash type. Now, this is one type of control circuit. This is one type of control circuit. But there is another type of control circuit in which for me, that is good compared to this circuit. Because aside from having the mechanical, the electrical interlock, the push button itself can be considered also as an interlock. Okay? Now, you will also observe that in this circuit, I am only using single terminal for forward. Then I am also using here single terminal for reverse. And then you have here the normally close. So this is forward, this is reverse, and this is off button. So try to look at it. Only single contact used in forward and reverse as well as in the off button. But if I'm going to introduce to you another type of circuit, this time we will be using a double contact or a brake make push button. And I will show you how. Okay? So this is now the contact or the control circuit using a double contact. You have it. Still the same. You have your overload contact. This is your overload contact. Line 1. Then you have your stop button. Okay. You have your stop button. Normally close. Stop or off button. Then this time, you will have a double contact. Okay? You have here a double contact for forward. So this is forward. Then you have also another one here for reverse. Then another double contact. Okay? So this portion here, of course, you have your interlock. Then you have your forward contactor or holding coil. So this is coming from reverse. And then remember that what we are using here is the double contact double contact push button. Now, here is the jumper. Now, in this particular push button, you have normally open and normally close contacts in every button. So this is a brake make push button, including this one, double contact. So what you will do, you will place jumper. Meaning to say, you will place jumper here. You will connect this motor. And then you have your jumper here. Okay? Now, this portion, this is for your reverse. This is your reverse. Line 2. Then coming from forward. Then you have your maintaining contact here. Coming from forward. And then you have also another maintaining contact here. Coming for reverse. Now, you have here the jumper. You have here the jumper. So, if I'm going to press the button forward, this one, so the contact here will move downward. Okay? So the normally open, the normally closed will become open, and then the normally open will become closed. So if you will press the circuit, the current will pass through here, energizing the forward. Then when the forward is energized, what will happen to this? This will open, because this is interlock. Then what happened to this? This will close. So when you release your finger from the button forward, the current now will flow through the maintaining contact. See? So, interlocking is still very important. Now look what happened. In the previous diagram that we have, then we have the interlock. If the forward is on, then you will immediately reverse. It will not work because of interlock. But this time, you need to be careful. But this time, if this one is on, energized and forward, then, again, unintentionally, accidentally, you on the reverse. This one, you on the reverse, while the forward is on. Then the motor stops. Look at this. Motor is running because you on forward, but you on immediately the reverse without stopping the motor. So when the contact is in the middle, the current flowing here is cut. So what will happen to this? De-energize. Then this will go back to normal position, and then this will open. Okay? But the motor is still running. Remember, the holding coil is de-energized or disconnected from the circuit, but the rotor, there is still an extra rotation. Then, just imagine the distance of the contact from normally closed and normally open, too near. Okay? So there is a tendency that when you press this button, this will touch here, energizing the magnetic coil of the reverse. Now, it is good if that is no load and at the same time small horsepower. But what if the horsepower is so big? Then there is an extra rotation and there is a load. So there is really a possibility that your motor might be damaged mechanically. So always put this in mind, no? presence of mind. That when you want to reverse the motor, you off first. And then, let the motor, rotor, in full stop, then that's the time that you will reverse. For me, that's a law. Okay? To prevent damage from your motor. Huh? So that is now the other control circuit of your forward reverse 3-phase motor. Now, what is the contact configuration or contact arrangement? So you have your contact arrangement here. Okay? This is your stop. Then you have your forward here, double contact. And then you have also another one here, normally open and normally close. Excuse me. Normally open and normally close, like that. Okay, so this is your off, this is your forward, and this is your reverse. Now, if you will ask me, sir, what is really the best? Well, for me, it is the same. It depends on how you operate. Now, remember, in this portion here, even without the interlock, provided you are using this, still the motor is safe. Okay? No short circuit that will occur. But a possibility that you energize the reverse while the forward contact is still on, that's only the disadvantage. Okay? So that is it. So if you will install, if that is only assembled, no, the forward reverse is assembled, I will recommend that the push button off should be on the center. Because if you will on here, you off, then you on. If that is in full stop. You on this one, you off, and then you on. See? So that is the advantage. So this is now the control circuit of your control and the power circuit of your 3-phase motor or the magnetic starter, forward, reverse. Remember the diagram. Remember the diagram. The first diagram and the second diagram, no, will be still the same diagram to be used if you want to reverse a single-phase motor. Okay, remember, the same control circuit to be used in reversing single-phase motor. So what is being changed here? Only the power circuit. Okay? So I might demonstrate this in the next video, the 3-phase. I already acquired a VFD, the variable frequency drive, to have a 3-phase here in my home. So the source is single phase, but the output is 3-phase. So we can run a 3-phase motor. It's just a small size of motor. The horsepower is maybe 1 horsepower. Then we have that available in our shop. So I will bring that motor here so that I can really demonstrate to you on how to connect a forward, a reverse, 3-phase, and single-phase motor. Okay? So let us now proceed to the next topic, reversing a single-phase motor. Remember, in capacitor start, if you want to reverse it, see to it that there are 4 leads out. 2 for running, 2 for starting. For running winding terminals, you have the beginning is terminal 1, and then the ending is terminal 4. While the starting, terminal 5, and then the ending is terminal 8. So at least there are 4 leads out coming out. Now, you just observe the power circuit compared to your 3-phase. We are still utilizing the 3 contacts of every contactor, though our input here is single phase because our motor is a single phase motor. So you will observe, no, so that we can trace the circuit. The jumper is like this. This is your first contact, second and third. First, second and third. You will observe that the first contact after the circuit breaker is connected to the third contact of your forward, and then it is also the same time connected to the last two contacts of your reverse. That's in the upper portion. While the line 2 is connected to the first contact of your reverse contactor. While below, number 1 contact in forward connected to number 1, then number 2 connected to number 3, number 2, and then number 3 is contacted to number 3. Then you have your terminal 1, terminal 4, terminal 5, and terminal 8. So let us trace the circuit. Okay, let us trace the circuit. Look at this. I'm going to press the button forward. So this will close. Okay? So the current will flow here. Well, look at this. The current will flow here, energizing the terminal 4. Terminal 1. Diba? You have a terminal 1. So terminal 1. Then, you will also observe from here, terminal 1, this is connected to terminal contact number 3 of your forward here. Then, since this is energized, so this is closed. So, terminal 1 and terminal 8 is contacted together, joined together. So, that is for line 1. While your line 2, this is connected directly to terminal 4, this one, terminal 4, and your terminal 5 is connected directly already here. So meaning to say, 4 and 5 are connected together. So the motor now is running forward. Okay? While if you want to connect this in reverse, if you will reverse this, this will open. So this is now closed. So look at, let us trace the circuit. So line 1 here, from here, line 1, here. Okay, look at this. This is your line 1. It will immediately go to your terminal 5. You have it, terminal 5. Terminal 5. And then, the other one here, this one, will go to your terminal, this one will go to your terminal 8. Okay? Look at this, terminal 8. So, you have your terminal 8 here. And then, we already connected also terminal 4. Why? Because terminal 4 is directly connected somewhere. And one. While the line 2, you trace the circuit, line 2, there, terminal 1. That's one. And then, where is the terminal 5? This one, where is the terminal 5? So let us trace the terminal 5. Okay? So the terminal 5 again, look at this. No? The terminal 5 again is connected directly to line 2. Like it. This one. So you will also observe that in this portion now, the terminal 5 and terminal 1 is connected together. So therefore, we interchange the 5 and 8. In the forward, you have 8 and 5. Then when you reverse, on the starting winding is interchanged. So the terminal 5 now is in terminal 1 and then terminal 8 is in terminal 4. So the motor is reversed. So just look at the diagram. Okay? Now you will be using the same control circuit that we are using in 3-phase. So don't be lost here. You can trace the circuit. Okay? Don't be lost. Don't be confused. So, you know, it is also nice that you can trace the circuit. That is very important. So this is now the power circuit of your single phase or reversing a single phase motor. Take note, when you want to reverse a single phase motor, see to it that there are 4 lanes, 2 for running and 2 for starting. Okay? So that is it. Now, there is also another way, because there are motors that having three leads out. Okay? So this is now a design. This can be found in the book, including the three-phase. But this time, I try to design a circuit that is, how would you reverse a three leads out motor? Okay? So, the same control circuit that you will be using, but the power circuit is now different. Okay? So here. Now, this is a three lead out motor. So you will notice that this is the common terminal, this is the forward terminal, and this is the reverse terminal. So if you will really have it, if you will really run this motor manually, so this is your line 1, and then you have this is your common, this is your forward, and then of course you have your reverse. Then you have a selector switch here, considered also as your selector switch for forward and reverse. Okay. So if I'm going to run it manually, I will switch on here. So line 1 and line 2, common and forward. If I'm going to reverse, I will just put it there. So line 1 and reverse. If I'm going to do it manually or using that selector switch. But remember, this is without a protection, an overall protection. So I'm going to use again the forward reverse. This is reversing a three leads out motor. Reversing a three leads out motor. So you have here. So if I'm going to on the forward, of course, the common is energized. Okay, the common is energized. At the same time, the forward is energized. So the motor is running. So when I press again this one, I will off. Then I will press the button forward. This time, the common is still connected in line 1. And then line 2 is connected to reverse. Okay, so that is very simple. Reversing a three leads out motor using magnetic starter. So that is one way in reversing a motor or reversing a three lead motor. Okay, so that is it. So very simple. Now I have also a motor there that is a three leads out. Now what is that motor? The wash motor or the spin motor of your washing machine. That is a three leads out motor. So if you want to reverse, you can reverse it using your forward reverse magnetic contactor. Okay? So our next video is still a forward reverse having an indicating lamps. You will know if there is power. You will know if the motor is rotating in clockwise direction. And then you will also know if your motor is running in reverse direction by looking only the indicating lamps. And then at the same time, I'm going also to give you the forward reverse jump operation and then the forward reverse dynamic brake. So those are the coming connections that I'm going to introduce to you. So much for this morning. So see you next video. Again, don't forget to like our video, subscribe, and if possible, share, so that others will also see our lesson. Thank you, and God bless us all.